Okay, everyone, I am presenting the Semantic Web 3.0. This is the content that you can see all information about the Web 2.0. Okay, so what is Web 2.0 technology in Semantic Web? The comparison of XML and RDF statements, what you can call tuples, and you can find out what RDF is, how we transfer or how we write RDF statements, and RDF vocabulary, RDF schema syntax in detail, and more about advance of RDF schema, and then OWL, Sparkle, URI. Okay, now let's find out what is Web 3.0. So basically, for short, Web 3.0 is a read, write, execute web, which understands pieces of data and connects them intentionally. We can call Web 3.0 because look at this, we call Web 1.0, Web 2.0, so it's simply likely might be called Web 2.0. It is a portable personal web, okay, connecting intelligent data, concepts, applications, especially people. Okay, now let's find out about technology that we use in Semantic Web. So why we need RDF? So basically, we all know about XML, okay? But XML, let's see the differences between XML and RDF. So look at that. So we know XML, but XML is used to read the data in. So in order to display the data on the screen, we need RDF, okay? And in XML, the main thing is representation is what matters in XML. But in RDF, the meaning is what matters in RDF. That's the reason why RDF is a better choice, because Semantic Web is about meaning of data, deals with data models than the model itself. Okay, so we have talked about RDF, but let's see how RDF looks like. Okay, basically when we search something on the internet, for example, we said the author of http www.w3school.com RDF is Jane Eagle Revness. Okay, so when we enter, behind the scene they will find out what subject of the statement is, what the predicate of the statement is, and what the object of the statement is. Okay, same thing with the other one. Okay, so the combination of a resource, property, and property values forms a RDF statement. Okay, now RDF. So what is RDF? RDF is a core data model, a foundation of Semantic Web. All data are represented as RDF, stored in RDF, retrieved in RDF, and sent in RDF. Okay, if you know or have played with Facebook app or Google app engine, you will see they're using the same technology in here. Okay, they're using Semantic Web to retrieve data, to store data. Okay. Now, RDF is not like a tabular data model of relational databases, not the same as the tree of XML world. It is a graph. RDF is a labeled directed graph collecting statements and store all the triples or statements in a RDF database we call a triple store. Okay. And now what's next? Okay. So look at that. So if you have a RDF, you can use this link right here to validate, just like we have a validation for XML file. Okay, this is a link that you can use to validate your RDF file. Okay, so basically you see the oval right there. It is a resource, and the link, it is the edge connecting nodes to each other, and labels are URI. Okay, and the rectangle is a literal node, yeah, that represent the value. Blank node is a resource without URL, URI. Okay, and if you want to play more about the RDF, you can use this link. Yeah. Alright, so how we wrap RDF statement and send over the internet. So we have many different ways. Okay, so basically RDF is an abstract data model. There's not a concrete representation of RDF. Okay, so it doesn't matter what valid visualization for RDF data you use, but Sparkle query language express them the same. Okay. Now you see that we have RDF / XML visualization, and triples, totals, GG, RDFA, notation 3, for short we call N3, because total is the most popular among all of them. Okay, because total is significantly more compact than RDF XML, more readable than Ansible, and lacks the first order logic extension from notation 3. Now let's translate the RDF graph into total. You see that we have 4 prefixes. Okay, so we predefine vocabularies so that we don't need to carry the whole thing every single time we use. And then the last 2 lines, they are triples. You see that? Each part are separated by white space. And at the end of each triple statement is a period. Okay. There it is. Yeah. And then RDF uses the same data type as XML. For example, XSD string, XSD float, XSD double, XSD integer, and XSD date. Okay. So, how we define the RDF vocabulary? Okay, vocabularies are very important in using, because RDF schema or WOL are using vocabularies a lot. So we have standard or common vocabularies. DC, that is Dublin Core, standard general purpose vocabulary for describing resource metadata, such as titles, creators, or we have friend of a friend, lots of vocabulary to relate to people, to each other, and to organization. And we have e-commerce vocabulary. Okay. Now, how we applied the RDF vocabulary into RDF schema. Okay, first of all, what is RDF schema? It is the most basic schema language used in Semantic Web. Okay, many of the most popular RDF vocabularies are written in basic RDF schema. Okay, RDF schema is similar to the universal translator. Different teams create the data for different users at different times, but data is still connected using RDF schema, Semantic Web technologies. Interestingly enough, RDF schema is object-oriented, describing classes of objects, while RDF is a graph database. However, RDF schema is expressed as RDF. Okay, again, like I said, total serialization is the most popular. So we use total serialization to create some RDF schema. Okay, we have prefixes. Yeah. And then we create some object, type, label, and we also use some prefixes. Okay. See that? Alright. And then let's see, syntax. Okay, so if you want to know more about syntax, you can read about this. This is RDF type, RDF class, and RDF as property, RDF as domain, RDF as range. Okay, and then we more advanced RDF schema, subclass of, subclass, subproperty of. Okay, and then our next thing. What is OWL? It is the web ontology language. It is the second core technology in Semantic Web. Just think OWL as a schema. Its two primary uses are fast and flexible data modeling, efficient automated reasoning. Okay. Even though it is a model language, it has many advantages compared to other modeling languages before it, such as XSD, UML. OWL is expressive. It is used to express extremely complicated and subtle ideas of your data. It is flexible. All data modeling statements in OWL are RDF triples and are therefore incremental by their very nature. Okay. And OWL is efficient. It comes with a number of built-in profiles that allow you to trade off the kinds of reasoning you would like to do against your individual performance goals. Okay? And then Sparkle, of course, we need to search for the data. Okay, so Sparkle is a query language in Semantic Web. This one is the third core technology of Semantic Web, along with RDF and OWL. Sparkle stands for Sparkle Protocol and RDF Query Language. Consists of two parts, query language and protocol. Like SQL, used to query relational data. XQuery used to query XML data. Sparkle is used to query RDF data. It operates over disconnected sources over a network, in addition to a local database. Sparkle protocol allows transmitting Sparkle queries and results between a client and a Sparkle engine via HTTP. Sparkle fundamentals. First, a Sparkle query is an RDF graph with variables, like you see in the example down here. Okay, so this is Sparkle query. It looks similar to the RDF graph. Just one little thing is we have a variable in the query. Okay, and to define a variable in Sparkle, we need to start off with a question mark. See that? Alright. A basic Sparkle query is simply a graph pattern with some variable. You see, with some variable. And it is a RDF graph with some variable. Variables in Sparkle queries start with a question mark, like I said. Okay? Next. Okay. What are return clauses in Sparkle? We have four very important ones: select, ask, describe, construct. Select queries return data represented in a simple table. They serve very much the same function as in SQL. Ask queries check if there is at least one result for a given query pattern. The result is true or false. Okay. Describe queries return an RDF graph that is created from a template specified as part of the query itself. Construct queries are useful if you have RDF data that was automatically generated and would like to transform it using well-known vocabularies. Now let's see one example of select clause. Okay, you see that we predefine the vocabulary, and then we select name from the database set, also written in RDF, and then where clause we can search against with a specifically name. Okay, and we can order the result based on the name or based on a column, a property that we wish to have. Yeah, and as I mentioned that resources and edges are URL. Okay, let's repeat that. The linking between things, resources, is the fundamental capacity of the semantic web.